Okay, so let me go a little bit more further in detail with that valid reasoning statement. We actually have a law. It's called Law of Detachment, or in Latin, modus ponens. And what this says is that if I have a conditional, so if P implies Q is true. Okay, so think back to our truth table. The only time that it would ever be false is if we have a T for P and an F for Q. Okay, so if I know that T implies Q is true, and I know that P itself is true, okay, then Q is true. Okay, this is what's called an example of direct reasoning, or more fancy speak, the law of detachment or modus ponens. Okay, so going here, if it is raining, the grass is wet. Okay, that's a true statement. We all know if it's raining that things are going to get wet, so grass is one of them. I also know now that it is raining, that it's currently raining. So can I safely conclude that the grass is wet? Yes. Okay, and I knew that because of the law of detachment. Yes, I know we would want to say I know that because it's common sense, but this is a logic lesson. So in logic, we would say that we're using the law of detachment on that. Okay, the next law is called indirect reasoning, or modus tollens. Can I go back there? If a conditional is accepted as true and the conclusion is false, then the hypothesis must be false. Okay, so I'm going to go back to what modus tollens is saying. It says I've got a linkage. I know that P implies Q. I know that's a true statement. But this time I know that Q in this case is false. So what does that tell me? So then I know that P has to be false. Okay, so again, that's an example of indirect reasoning or modus tollens. So going back to our example here, if it is raining, the grass is wet. Okay, I think that's a true statement. Anytime it rains, grass is wet. We just talked about that. However, I look outside and I see that the grass is not wet. Okay, so what does that tell me? That tells me the only way that the grass cannot be wet is if it is not raining. Okay, so that the P itself has to be false. And again, we would want to say that's just common sense. I understand. It's just how we think. But in logical notation, we're illustrating indirect reasoning or modus tollens. Okay, the chain rule is a link of several conditional statements that allows us to create a third conditional statement. Okay, so for example, and I'm going to switch letters on us, so I hope this doesn't cause too much trouble. So if I know that A implies B is true, and I know B implies C is true, then what can I then conclude? I can conclude that A, the first statement, should imply the third statement. Okay, and anytime we're doing that, we're applying the chain rule of logic. Okay, so here we go. If you eat well, then you will be well. There's our B. If you are well, then you are happy. There's our C. Can we conclude that if you eat well, then you're happy? Yeah, that's in the way we can conclude that again is through the chain rule. I know we want to say common sense, but we're applying the chain rule of logic. Okay, so we're going to take a couple of these chain statements and try to come up with the conclusion using the chain rule. If a triangle is equilateral, then it's isosceles. If a triangle is isosceles, then it has at least two congruent sides. Okay, so let's look at this. So we're saying if it's equilateral, then it's isosceles. If it's isosceles, then it's got two congruent sides. So what is our chain conclusion that we can make off of this? We can say if a triangle is equilateral, then, and then I'm going to tie in the C statement, then it has at least two congruent sides. All right, let's do that with the next statement. If a number is a whole number, then it's an integer. If the number is an integer, if the number is an integer, then it's a rational number. And we're going to one more. If it's a rational number, then it's a real number. Okay, so we've tied together 4 statements. So what overall conclusion does it allow me to say? I mean, it allows us to say if a number is a whole number, then it is a real number.